In this video, I want to have a look at electricity in the home. So the first thing you need to know is how we measure electricity. So the watt is a unit of power and it's equal to 1 joule per second. So because we're talking joules per second, that means that a watt is a rate. We also need to know that the symbol for watt is a capital W. Now the watt is the most basic unit, which is this one here, and like we said, it has that symbol of W. Probably the next most common one that you'll come across is the kilowatt. So kilowatt is little k and then capital W, and it's 1000 watts. We could also write it as 10 to the power of 3. If we go up again, we can look at megawatts, which are 1000 kilowatts. So that's gone up 1000 and then up another 1000, so we're at 10 to the power of 6 now. And then gigawatt, 1 gigawatt would be 1000 megawatts. So that means we're now at 10 to the power of 9 watts. If we want to look at smaller units, we can have a look at milliwatts, which is 10 to the power of minus 3. So that means going from watts to milliwatts, we'd be dividing by 1000. So we can use these multiples, these powers of 10, or we can either multiply or divide by 1000 for every step that we go up or down that table. Let's have a look at a few examples of converting between different units. So our first one asks us to convert 8,500 watts into kilowatts. So because we're going from watts to kilowatts, we're going into a bigger unit, which means that our number is going to become smaller. Now because we've gone one step, we're going to divide by 1000 or divide by 10 to the power of 3. So that means 8,500 watts is going to be equal to 8.5 kilowatts. So we've divided by 1000. For our next one, to get from megawatts to watts, we're going up 2 steps this time. So we're going from a big unit to a small unit, means our number's going to get bigger. And because we've gone 2 steps, we're going to times by 10 to the power of 6, or times by 1000 and then times by 1000 again. So we're going to have 2.6 times, we're going to have 260 times 10 to the power of 6. But we want to write that whole thing in scientific notation to make it a little bit neater. So 260, we'd write that as 2.6 times 10 squared, because that decimal would have had to move 2 places. And then we've also got that times 10 to the power of 6 on the end. So that's going to become 2.6 times 10 to the power of 8, because we add those indices. All right, our last one then. We've got 17,500 gigawatts to kilowatts. So giga to kilo is 2 steps again. So we're going to do that same calculation. We're going to times by 10 to the power of 6. So we're going to have 17500 times 10 to the power of 6. Again, if we convert just this 17,500 into scientific notation, we'd have 1.75 times 10 to the power of, and we would have had to move that decimal if we want it there. That's 1, 2, 3, 4 places. So 10 times 10 to the power of 4, and then we've still got that 10 to the power of 6, which means we're going to have 1.75 times 10 to the power of 10, and that's kilowatts. So this one should have been watts on the end there as well. So we measure electricity in watts, but when we're talking about how much electricity something uses, we measure it in watt hours. So 1 watt hour is the amount of electrical energy that a 1 watt load draws over 1 hour. So the electricity usage in, say, houses or buildings is usually measured in kilowatt hours, because watt hours is very small. Then if we're talking about how much electricity costs, we're talking in cents per kilowatt hour. So we've got an example here that asks us to calculate the cost of 15.6 kilowatt hours of electricity if the electricity company charges 23.84 cents per kilowatt hour for the first 10.9 kilowatt hours, and then it charges 22.705 cents per kilowatt hour for the remaining usage. So anything over that 10.9 is charged at a cheaper rate. So to do that, we've got our first 10.9 kilowatt hours is charged at 22.84 cents per kilowatt hour. Now, because we want our final answer to be in dollars, let's convert that to dollars now. So we'd have 0.2384. So that's our first 10.9. Then we're going to add on whatever's left over. So to figure out what's left over, we're going to go our 15.6 minus 10.9. That'll tell us how far over the 10.9 we've gone. And then whatever that answer is, we're going to multiply it by our 22.507 cents. So again, turning it into dollars, we'd have 0.22507. Then we put that whole thing in. You can do this as two separate calculations as well, if that makes it a little bit easier, but you should end up with the same amount. Now, because we're talking about money, we're always going around to two decimal places when we're talking dollars and cents for our final answers. So we'd end up with $3.66 for those 15.6 kilowatt hours. One other thing that's important to consider is that in some states, if you've got a special electricity meter, you can be charged different amounts for your electricity depending on what time of the day you're using it. So domestic or peak electricity is electricity that you're using when the demand for the electricity is the highest. So that would be during the day or on weekdays. Then you've got off-peak electricity, which is electricity usually that's used overnight because there's not as much demand. So this is just one example. So peak electricity time is between 2 p.m. and 8 p.m. on a weekday. Then there's off-peak, which is from 10 p.m. to 7 a.m. And then there's this shoulder period, which is sort of halfway between peak and off-peak. And it is different for weekends and public holidays as well. So I just want to finish off the video looking at one example of calculating electricity costs for a household where we've got different amounts of electricity used at different times of the day. So in this one, we're given 3 different amounts of electricity that have been used. We've got at peak time, shoulder time, and off-peak time. And because they're at those different times, we've been given 3 different amounts that our electricity is going to cost. So you can do this as 3 separate calculations and then add all your answers together. I'm just going to do it as one calculation. So we're going to have 762 kilowatt hours, and that's charged at 40.611 cents per kilowatt hour. So I'm going to again change that to dollars. So we're going to multiply by 0.40611. So that's just for our peak time. Then we're going to add on our shoulder time. So we've got 514 kilowatt hours. And it's charged at 20.26 cents. So changing that to dollars, we'd have 0.2026. And then our last one, our off-peak usage, we've got 288 kilowatt hours, and it's charged at 11.445 cents. So 0.11445 once we change it into dollars. And then if we figure all of that out, the total cost of that electricity is going to be $446.55. So that's just an introduction to a few concepts that we need to know when we're looking at electricity usage in the home.